slide 1. Now, this is a power-up. Everybody, I want you to answer this. This is kind of quick drill like the last one. Roper does 20 push-ups per minute. If he can do 50 push-ups at this rate, how long will it take?
To do 50 push-ups?
Okay, yeah.
Maybe slow. 2.5 minutes.
2.5 minutes. Very good. Can you explain your reasoning?
Well, 20 times 2 is 40, and then half of 20 is 10. 40 plus 10 is 50.
Very good. Okay, so now this one.
Oh, 30.
Wow. How'd you do that one so quickly?
Because the 2 times 4 plus 1 is 5, and then you cancel out the 2, so 5 times 6 is 30, and then 1 is 5.
Yes, excellent. All right. What about this one?
Oh, I still don't know how to do these.
Okay, well this is, think.
Because like we don't have a protractor.
No, you don't need a protractor. You need to know how many degrees in a triangle. No, it doesn't. It's fast.
Oh, okay, I get it.
You get it?
X is 40, right?
No.
Isn't it 190?
How many degrees? Think about it.
It's 50.
It's 50. Because why? Why?
50 plus 50 is 100. 100 plus 80 is 180.
Very good. Okay, so we have to have, look at this. Everybody, watch. I'm going to write it on the board here. We have 180 degrees in every triangle, yes?
Yeah.
Okay, take away the 80 that we already see right here. Okay, so we're going to take this away from the 180. And now what are we going to do? Okay, so we have 100 left.
You gotta split it into the...
Don't we have to split it in half? How do we know? Because it's x and x, which means that it's not two different angles, it's the same. So we're going to split that in half and get 50 and 50. Does that make sense to everybody?
Yeah.
Okay, so x is 50.
You're fine, like...
Yeah, and I moved this over here. Sorry about that. It's hard to write on here. Okay, so now, everybody...
X is 9, I believe. Wait, no.
Come on, guys.
X is 6.
Nope. 7. All right. Who said 7?
Me.
All right. Go ahead and explain.
Well, I kind of just went off. I didn't fully solve it. I just went, well, 4 times 6 is 24. And it's minus 3. So it has to be whatever's after 24.
Who thinks that's the hard way to solve it? Okay, how would you have solved it?
Subtract the 25 and then you get the answer for multiplication.
Oh, wow. Nobody's got the easy way to do it? Come on, y'all are making things that are too hard for me. Everly.
Don't you add
Oh.
4 to 3?
How about if I add a 3 to both sides?
Yeah. 1 for us.
If I add a 3 to both sides, then I have 4x is 28.
Oh, I
Already
remember this last year. It
complicated.
took me like 3 weeks.
Okay? Is that hard? Mentally add 3 to both sides, and then you get 4x is 28. Divide by 4 on both sides, and you get x is 7.
Oh.
Okay, isn't that easier, guys?
I mean,
What?
once you realize, yeah.
Okay, so here we go. Now what? Remember to put it into money.
It's not multiplication. No, wait.
Of is multiplication. 22. 22 what? $22. Very good. Now, how are we doing that? We're saying of means times, right? So we're going to cancel out the 5s, and we're going to get 11. It is hard to write on this thing. 11 and 1. 2 times 11 is 22. Okay? Everybody got it? Understand? Okay. Walking up 3 stair steps, Vera rose 2 feet. How many feet did Vera rise walking 12 stair steps?
8.
8. Explain your reasoning.
Well, 3 times 4 is 12, so I just multiplied 2 by 4.
And where'd you come up with the 4? Okay, okay, so you did a proportion. You said 3 is to 2. Okay, so basically 3 steps is to 2 rise, right? And then 12 is what it went to, so isn't that going to be multiplied by 4? Multiplied by 4 to get 8. Okay, so you could do that with proportions.
That's not what I...
Okay. Now, 25%. I don't know why I did that one. Okay, I did that one for you, kind of, didn't I?
Safely determined,
Okay.
based on that work, it is 111.
111. Okay, I don't know why I did that one for you. But anyway, 25% is the same as 25 100ths, which is the same as 1/4. And we can see that if we take 1/4 of 444, that's dividing 444 by 444, and we get 111. Right?
And we get
111.
That's so much.
I don't want to show you this one. I don't want to. Okay, now this one.
That one was easy.
I know, but this one's a speed one. So you have to, everybody, I want you to see it at the same time. Are you ready?
Sure.
Bro, how is that a speed one?
Well, you're supposed to, the first one that gets it gets a piece of candy.
Wait, what is
How
this?
that?
What?
That's huh?
What does the one?
Oh,
and
the
then
first one's 10.
Yeah,
The second. How is there a thing?
The
for
first
second
one's 9. but we
I'm
don't-
trying to do it in my head. Would y'all hush?
Wait, Miss Aubrey.
I don't know what that square root number
Zero.
What
Zero.
kind of
The answer's
problem
zero.
is this? It's just
Zero.
like there's a comma.
Okay, so you're when it has the radical, you're,
Hold on. Okay.
Answer 0.
when it takes the radical, you're taking the square root of what you have then.
Okay.
So it's a series of steps. If it says square root, you're taking the square root of the number you have in your head. Okay? All right, so if you have the answer, go up and put it on the board.
0. Go up here.
Okay, go put it up if that's your answer.
No, I'm sorry. Yes. I told you. 0. Man, you get the credit for it.
Who's got it?
Hold on.
I think.
I finally figured out what it was.
I think I have it.
Finally,
See, 7.
It is 7. You are correct.
we're 7 away.
Explain your 7, Mr. Brady.
Oh, well, 100 squared is 10.
Square root.
Yeah, you know what I mean.
We're that far.
Minus 1 is 9. That gets 3. 3 times 12 is 36. That squared,
Square root.
square rooted, is 6 times 4, that's 24. Plus 1, 25. Alright? And then the square root of 25 is 5. Times 10 is 50. Minus 1 is 49. And then the square root of 49 is 7.
All right, very good. The answer is
That
7.
was
The longest.
Okay, now, you guys, we should be able to do that. Here, definitely.
That's just really hard process.
I know. I think I'm on the big one. Uh-oh. You'll get 2. Although you've probably earned that many by now, but, okay, so, now let's go to this one. We are on our lesson now, okay, and we're going to just start talking through, but we're going to continue to work them because I did not do the lesson beforehand. So I want y'all to be just as engaged in the lesson as we just did that, okay? So we're talking about the exponents. Law of exponents is what this lesson is all about, okay? So it says, recall that counting number exponent indicates how many times a base is a factor. So basically right here, we've got what exponent, a good definition of exponent, right? X to the n equals x times x times x n times. So we're going to have n of them. And then it says, applying this knowledge, we can begin to develop the law of exponents that describe relationships between exponents for certain operations. Okay, so now, go to the next one. It says, find the missing exponent. Now, I did this one for you. That's 3 to the 5th over 3 cubed. Now, what we're going to come up with is a law of exponents that's going to tell us this. When we're dividing two like bases, we subtract their exponents. What's 5 take away 3? 2. So we should get 3 squared by the law that we are developing right now. Okay? So, but I wrote it out, I expanded. What is 3 to the 5th? It's 3 times 3 times 3 times 3 times 3. And what is 3 cubed? It's 3 times 3 times 3. So then we could, oops, that didn't work very well. Cancel, 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 and what am I left with? 3 times 3, which is 9. Okay? So, the rule is that when we are dividing like bases, we subtract the exponents. Easy, easy. Okay? Now, here they're coming up with 3 rules that we're going to learn. Okay? So let's write these 3 rules up here so that we have them in front of us as we're doing our class. So you should be taking notes on this because this is your notes. I'm going to post the video online. This is going to be a reasonably long video because we're doing it real time.
I hope the video can hear you.
So, x to the a times x to the b equals x to the a plus b. Who can tell me what I just did? Okay, Kira. Express in words that rule. If you have like bases that you are multiplying together, what are you going to do with the exponents?
What's the date?
Add them. Okay? Now, doesn't this make sense? If we have like bases that we're dividing, then we subtract the 2 bases. Multiplication and division are inverse operations. Where's your paper to take your notes? Logan, you need to get engaged here. All right? So, we've got division is going to give us the subtraction of the exponents. Multiplication is going to give us the addition of the exponents. It makes sense, doesn't it? Okay? And then the last one is when we raise a power to another power. So an exponent to another exponent. Then we multiply the 2 exponents. So x to the a b is x to the a times b. All right? So when we raise an exponent number to another exponent, a power to a power, we multiply the 2 powers together. Okay? And that's it. That's what our lesson is today. It's just learning to master these 3 rules. Okay, so does everybody, you've got them on the board, so I'm not going to dilly-dally those. Those are the laws for exponents of multiplication and division and raising a power to a power. Okay, so A, who can tell me? Okay, we're going to have 10 on the bottom. We don't change the base. Okay, so yes, 10 to the 14th, because when we multiply like bases, we add the exponents. Very good. What about B?
10 to the 48.
10 to the 2, right? And since 10 to the, well, 8 minus 6 is 2. Because it's division, we're going to subtract. But then 10 squared would be small enough that I would want you to simplify it. Okay, so 10 squared, we would just say 100, right? And then if it's something you should know easily, go ahead and simplify it. All right, so now they're just giving us the solution of those, so we already know that. Find the missing exponents.
10. Wait, no.
Very good. 7. You're right. Mrs. A almost went for that one. Okay, x to the 5th times x to the 2. When we multiply, we add, and we get x to the 7th power. Okay? Nobody?
3.
X to the
Oh, I was
third.
writing down the other notes.
Very good. Go. Okay, so now we're on D.
What was B?
Okay, B, what was B? Is everybody, okay, we need to backtrack because we didn't have our packets.
No,
Are we on our practice now?
Yes.
Okay,
Are you sure?
so what was that one? X to the
7.
7, what's this one?
3.
X to the third, what's this one?
6.
X is 6. When we raise the power to a power, we multiply. Okay, so now, let's see if I can get this one out of my face. All right, so what's 2 cubed times 2 squared?
2 to the 5th.
2 to the 5th. Very good. 2 to the 5th. Now, 2 to the 5th is a very easy one to evaluate. It's one of those we should always kind of memorize. 2 times 2 times 2 times 2 times 2 is 32. Okay, 2 to the 5th is fine, but you're going to get very quickly where you go, oh, that's 32. Okay, what's this one?
2 to the 3rd.
2 to the 3rd, and what is 2 to the 3rd? 8. 2 to the 3rd is 8. Excellent. Okay, so this one right here, the 2 is kind of hidden by my video.
2 to the 10th.
2 to the 10th. Now, 2 to the 10th is a little bit bigger, so you can just leave it 2 to the 10th.
But on F it says we have to answer them. Wait, wouldn't D be 2 to the 64? Like,
B, what'd you say?
wouldn't D be 64?
D? Okay, so 2, since I'm raising, so basically I'm multiplying, so I add the exponents. So 2 to the 5th is 32. 2 to the 6th is 64.
Oh.
Okay, so, no, that one's right. And this one is 2 to the cube. This one is 2 to the 10, which is 2 to the, yeah, it's bigger. It's harder to figure out. We don't have to figure it out. All right, now it says, write each expression as a power of 10. So let me get this over here. All right, so now 10 to the 6th times 10 to the 3rd is what? 10 to the 9th, very good. And 10 to the 9 simply means we've got a 1 with 9 zeros. That's a big number. Okay, so if we were going to write it out, it's 1, 1, 2, 3. Oh, I shouldn't have started this. It takes me so long to write on this thing. And it's sloppy. Sorry. So 1, 2, 3, comma. 1, 2, 3, comma. 1, 2, 3, comma. Who wants to read that number for me?
Me.
What is it?
That is 1 billion.
1 billion. That's a lot. Okay, what about this one?
10 4. 10 over 10.
10 4, good buddy. 10 to the 4th. Okay, now 10 to the 4th would be what? 1 with 4 zeros. That's not quite
Wait, no. 10,000.
10,000. Very good. All right, excellent.
Oh, what is F?
All right, so that was G. F is right here. 2 to the 10, right?
Would it just be 2 zeros at the end? Be 1,000?
What? No, that's 2 raised to the 10th power, not 10 raised. Yeah, it's going to take a while to figure out.
What's A, B, and C?
Oh, well, let's come back in a little bit, okay? We're going to go ahead.
A, B,
And,
and C were 7.
okay, all right, everybody. Cynthia planted. Now, this is number 1 of your problem set. Cynthia planted 12
What
potted.
was H?
Oh, we just did the practice problems. Oh,
10,000.
I was stupid.
Okay. Cynthia planted 12 potted plants in the last 3 weeks. At that rate, how many would she plant in 5 weeks? Okay, so let's figure out. She planted 12 in 3 weeks. So don't we need to find out how many she's doing every week so that we can then multiply by 5? So how many, could you, Logan?
Yeah.
What are you doing?
I'm just spinning.
This is what we're doing. Good. What is it? What is 12 in 3 weeks going to be in 1 week? Anybody want to help him out? Okay, not per week. What is per week?
Wait.
4 per week. Okay,
Yeah,
so
that's 20.
4, I know, but I'm asking it in pieces, right? 4 per week is going to give us, in 5 weeks, 4 times 5 is 20 potted plants. Okay, so you had the whole answer. I was trying to get you to give me the partial answer. All right, number 2. The volleyball team has 5 wins and 7 losses. What fraction of their games will they have won if they win their next 3 games? Okay, so they have 5 wins. They have 7 losses. So this is wins. This is losses. And then it says they're going to win the next 3 games. So what's their total win? 8. Okay, so what is going to be the fraction of the games that they will have won?
1.
Logan, are you marking on things with the pen?
No.
Okay, just keep the pen from marking on school property or touching school property. It's supposed to be writing on your paper, right? Okay, so not on the curtains. Okay, so here we have 7, 8. How many games altogether? 15. So what's the fraction? 8 out of 15. Very good. And 8 out of 15 does not simplify in any way, so I'm done with that, right? Okay, number 3. Of the 2008... Could you do that later instead of interrupting what we're doing now? We're on a different problem, so do the one we're doing now. Okay, you got to show work anyway. Of the 2,800 visitors to the fair, only 3 out of 70 won a prize. How many visitors won prizes? Who can tell me? Who can do that math almost in your head? Nine?
Wait, hold on.
There were 2,800 visitors to the fair.
Maybe 200 maybe. 90?
Okay, let's think here.
Wait,
We got-
wait.
Yes, go ahead. I'm just going to write it out so that you can see it.
I know 70 goes into 20.
Isn't that going to be a times problem? Because it's 3/70ths of, so isn't that 3/70ths times? Okay, so I'll write that. Does that help at all?
I know 70 goes into 28. My brain is farting. I can't.
Okay, can we cancel out that 0 and that 0? Does that make it easier?
4 and 2 cents. Because if you cancel out the 2.
Okay, you're losing a 0 there, sweetie. So basically, look, we got 280 divided by 7. 28 divided by 7 is 4. So when we cancel this, wouldn't this be 40
Yes.
to a 1 down here?
Yes. That would be 120.
120. Okay, I don't know what y'all are doing, but you're not using your canceling right, are you?
Yeah,
Okay, does everybody see why that should be an easy process?
I was canceling right.
Okay, so this one goes out because it matches a 0 down there. It always has to be numerator with denominator, right? And then the 28, we know, divides by 7. And this remaining 7 divides by 7. And then we have this one little 0 stuck there that didn't get canceled. So 28 divided by 7 is 4, but then we got the little 0, so it's 40 times 3 is 120.
Yeah, I was tripping up on my zeros, but
No tripping on zeros. Okay, so reflect the point 1, 4 across the y-axis. What is the image? What does a reflection mean? Remember, reflect is to flip over, right? If we're flipping over the y-axis,
it's minus.
which way are we going? Are we going this way or are we going this way?
Left.
Okay, we're going to flip from left to right. If we're flipping over the y-axis, because remember the y goes up and down. So if we're reflecting across the y-axis, it's going to be a left, right, flip instead of an up-down flip. So we
Minus
have to figure,
1 positive 4.
figure out where. Okay, so Braden says -1 positive 4. Now let's graph and see if we all agree.
I say minus one.
Okay, so here we go.
Same difference.
All right, so here we go. 1, 4 was our original point. So we would go right 1 and we would go up 4, right? Does everybody agree that 1, 4 is right there? And here is my y-axis right here. So I'm flipping over the y-axis to the matching point on the other side, which indeed would be -1, 4. Very good. Great. Anybody have any questions on that? This one. Classify what transformation is shown at the right. Enlargement, what big category does enlargement go into? Dilation. Very good. Dilation. So, because it's getting bigger, it's changing size. Remember, which ones don't change size? Reflection, rotation, and translation. They don't change size at all. This one is definitely changing size, so it has to be dilation. And so we'll put dilation. It's easier to write in cursive, even though it's still messy. Okay. And if this figure is rotated 90 degrees clockwise, draw the image. Okay, guys. This is a little dyslexic. Which way is clockwise? Okay, so you've got a figure that's like this right now, and you're going to rotate it. Now, they didn't tell you about what point, so I would just pick a point. I'm just going to pick a point of rotation. Remember, rotation always has a point. So I'm going to pick that as my rotation point. And then, if I'm rotating the whole figure about that point, like that point's a hinge, okay, and it's going to rotate 90 degrees towards the way a clock goes, then wouldn't the new figure be something like that? Does everybody see how I'm rotating this 90 degrees and everything else is just following that 90-degree rotation? Okay, everybody good on that? So I even gave you extra problems. This one, number 7, simplify. You got to do it in pieces. What's 3 squared?
6.
No,
9.
Okay, 3 squared is 9. What's 3 to the 1?
3.
What's 3 to the 0? 1. Any number to a 0 power is 1. Very good. The answer is 13. Okay, this is something a lot of people miss. 3 to the 0 power is not 0. 3 to the 0 power is 1. If you didn't know that, make sure you know it because it could be on your test real soon. And the end. All right, so what I want to do is take care of any business. Let me go ahead.